This conference will now be recorded.
So in the last class, we have seen about multi-threading. The main use of doing with threads is to increase the performance of application. CPU will allocate separate time for our threads. And whenever we want to create a thread, just we have to create a class which extends thread class and override the run method. And how to invoke run method using start. Right. And we have seen the methods of thread class. Today, let us go with one more example. Multi-thread demo. Open Eclipse. We have created a threads package. Right click on threads package and say new class multi-thread demo with main method inside. Now let us create a class thread X which extends thread X which extends thread. So whenever you want to create a thread, what is it? Just we have to create a class extends thread. Override the run method. Override the run method. And in this we need to go with the logic. Let me take the current details of thread. How to take? Thread t equal to thread dot current thread. So what is the need of calling this method? When you want to change the name of the thread or priority, then it is required to call this method. Now let us change the name t.setName to threadx. We are giving the name as threadx. Now in this threadx, we want to print from 1 to 10. So to print for int I equal to 1, I less than or equal to 10, I plus plus. And here we'll say in SOP t.getName, which returns the name of the thread, that is threadx, and a separator colon and the value of I. How to invoke this run method from main thread? So main is also a thread here. So how to invoke? We have to create object of threadx t1 equal to new threadx. Threadx t1 equal to new threadx. Then invoke run method only by using what? Start. Only when you say start, the object will become thread, then it is going to invoke run method. When you create threads only, CPU can allocate separate time for your threads here. Right? Now, let us run this code up to here. So when we run, see, we are getting threadx 1 to 10 here. Yeah, just a second. Hello, Gautami.
Hey, hi Raj.
Yeah, hi. Yeah, just we have taken one more new code here, multi-thread demo. In this, we have taken a class threadx which extends thread, and we have overridden run method. And we are taking the current details of thread using current thread method and changing the name to threadx. And just we are printing from 1 to 10. We are printing the value from 1 to 10. In the main thread, we are creating object of threadx class and we are invoking run method using start. Now see, when we run, we get threadx 1 to 10 here. Now let us create one more class. I'm creating one more class, thread y extends thread, override the run method and take the current details of thread. How to take thread dot current thread and let us change the name to thread y. Now in this thread y, let us display the numbers from 10 to 1 reverse way so that we can differentiate easily. For int I equal to 10, I greater than or equal to 1, I minus minus. And here we'll say t dot get name, which returns thread y and a separator colon and the value of I. Coming to main thread, create object of thread y, t2 equal to new thread y, and invoke run method using what? Start method. That's it. Now see, when we run, see the output here. We are getting threadx 1 to 10 and thread by 10 to 1. We are not finding any multi-threading here. Let us run the code again. Let us run the code. Same output. Let us run the code again. I'm keep on running because we don't know how CPU allocates time for our threads. So I'm keep on running. See now. Now this is the it's going to thread X. It's going to thread X. See here, 1 second. It's going to thread X 1 to 4. See the output what we are doing. See in thread X we are printing from 1 to 10, right? In thread X we are printing from 1 to 10. In thread Y we are printing from 10 to 1. But see the result. How we are getting? See the result here. So when we run the program, it's going to run method of thread X. It's going to run method of thread X, and the loop is repeated for 4 times only. And after that, it's coming out of run method. It's coming out of run method and allocating time to run method of thread Y. And see, it's giving time to thread Y. And see the output here. It's going to thread Y 1 to 10. And after that, again coming out and allocating time to thread X here. Allocating time to thread X means when the run method of thread X is getting executed, when the run method of thread X is getting executed, it is even coming out and allocating time to run method of thread Y. Okay, let me run the code once again. Let me run the code again. I'm keep on running. Now see here, this one is good. See, it's allocating time to thread X 1 to 5, coming out and allocating time to thread Y. Again, it is coming out of thread Y run method and allocating time to thread X.
So why the
Again
thread
coming
Y
out,
is in descending order? So
I
thread
said
Y
here,
starts from 10.
I said no, it's from 10
Okay.
only.
Oh, because of the
Okay,
descending order
right.
minus.
Yeah,
Yeah.
yeah. To differentiate, I'm doing like that. See here, again going to thread Y. Okay, again going to thread Y. After that, coming out and allocating time to X, Y like that. So means what is happening when run method of thread X is getting executed, it is even coming out and allocating time to run method of thread Y. Again coming out and allocating time to run method of thread X. Again coming out and allocating time to run method of thread Y. So in the case of ordinary programming, when we call a method, until the total method is complete, CPU will not give time to other methods until it come out. But in the case of threads, when a method is getting executed, it can even come out and allocate time to other methods also. Means CPU won't sit idle at all. So when CPU is not sitting idle, the performance of your application will get increased. Clear all of you? Right? The meaning of threads? Now, instead of start, if I go with the run, instead of start, if I use run method here, then when we run the program, how many times you run, the output will remain same. The output will remain same, thread X 1 to 10, thread Y 10 to 1. How many times you run? Because it's an ordinary program. When you say t1.run, it will go to run method. Until total run is over, the CPU will not allocate time to other methods. It won't come out at all. When you say t2.run, it will come to run method of thread Y. Until total run is over, your CPU will not allocate time to other methods. That's the reason always we have to create a thread only by using start. So without start, no concept of threads here. Right? Now, once we print thread X colon 1, we want to make the thread to go to block state. How to make the thread to go to block state? By using the method sleep. Whenever you want to make the thread to go to block state, we have to call the method thread.sleep of 1000. Means for 1000 milliseconds, for 1 second, the thread will go to block state. And see, sleep method, we are getting error because it throws interrupted exception. So checked exception. So keep the coding, try and catch block. Similar way, once you print a thread by colon 10, we want to make the thread to go to block state. Then we'll call the method thread.sleep. Keep mouse pointer on error and say surrounded with try catch. Okay. Now see when we run, It's going to display slowly because thread x colon 1, then thread x goes to block state. Since CP is free, it's allocating time to thread y. Again comes out and allocates time to thread x. So whenever you want to make a thread to go to block state, we make use of which method? Sleep method. Sleep method. So what is the use of sleep method? When sleep method is invoked on a thread, the current thread, whichever the thread invokes sleep method, the current thread will go to block state. You go to block state for the given interval of time. For the given interval of time. Like example, if you say thread dot sleep of 1000, so here 1000 is milliseconds. 1000 milliseconds means 1 second. Right? Now, let us move to the next one. Creating threads using runnable interface. Creating threads using runnable. So first of all, let us understand when you are able to create a thread using thread class. When you are able to create a thread using thread class, then what is the need of going with runnable? In what situation we have to create a thread using runnable? Let us understand that. Now, for that, like example, if you take, let us create a class A and we are creating class B, and class B extends A. Now we want to make this class B as a thread. Then how to do? We have to say comma thread here. Comma thread. So what will happen in Java? It will go with error, because in Java a class can extend only one class. If you try to extend multiple classes, goes with error because does not support multiple inheritance. Now in this situation, I want to make B class as thread. In that case, we go for runnable interface. So we say here class B extends A and say implements runnable. Implements runnable. And here, once we implement runnable, now it is mandatory to override the run method. When you extend thread class, it is optional to override run method, but when we implement runnable, it's mandatory to override run method. So when to think of runnable interface? If a class extends another class, if a class extends another class, and to make this class as thread, the class should implement runnable interface. The class should implement runnable interface, as Java does not support multiple inheritance. One more advantage of runnable is ensures that run method is overridden. Ensures that what run method is overridden. Now, let us understand with the program. Runnable demo. Right click on threads package and say new class runnable demo with main method. Now, in this, let us create a class thread R implements runnable. Implements runnable. See, we are getting error under thread R. See the error message. The type thread R must implement the inherited abstract method run. So now it is mandatory to override run method. So if you just click here, add unimplemented methods, the method will be overridden. And what is this override symbol? We call them as annotations. So by seeing this override, we can easily know that This is a overridden method. So this we call them as annotations added in Java 5 version. So is it mandatory to override at the rate override? Optional. But saying this, we can easily say that this is a overridden method. That's the need of going with annotations. Okay. So we'll discuss more on annotations later once again. For now, whenever you see at the rate symbol, you remember it is annotation. We'll be learning so many annotations in future. Okay. In this run method, let us display the values from 1 to 10. Some logic, any logic. Only the main objective, how to invoke run, is the major objective of this code. Just we are printing the values from 1 to 10. Coming to main thread, create object of thread r t1 equal to new thread r. Invoke run method by using what? Start. We have to invoke run method only by using start. But when we say start, what is happening? We are getting compile time error, because in thread r there is no start method. In runnable interface also there is no start method. It contains only one method run. But the rule is we have to create a thread only by using start. But there is no start method over here. Then start method belongs to which class? Thread class. Then what you do? You create object of thread class. You create object of thread class. Then invoke start method using thread class object. When you say t.start, now no error. But see the output what we get? Empty output, no output at all. No output. Because when you are referring to this object thread, when you say t.start, it will go to run method of which class? Thread class. It will go to what? Run method of thread class. And what is mentioned in the last class? Run method of thread class is empty method. There is no code inside the run method of thread class. It's an empty method. That's the reason when you say t.start, we are not getting any output. But the objective is we want to invoke run method of thread r. How to invoke? To the constructor of thread class, to the constructor of thread class, pass your runnable object as argument. Pass this runnable object as argument. Now since t is referring to t1 object memory, now when you say t.start, it will go to run method of thread r. See now when you run, we get the output here. So when you go with runnable, only one line extra we should write in our program. We have to create object of thread class. To the constructor of thread class, you have to pass your runnable object. So this line will become extra when you go with runnable interface. Got it everyone? Any questions? Right? No. Let us move to the next and important topic. Synchronization. So let us understand more of synchronization using a diagram. Now, here let us consider we are having a bank account. We are having a bank account with a balance of something like 5,000. Now, X is going to access this account. Y is also going to access the same account. Now, when the same account is accessed by multiple customers, then what type of account we call? In banking terminology, what type of account we call? Right? We call it as joint account. We call joint account. Now, let us suppose At time t1, x checks balance. At time t1, x checks balance. So what is the balance here? 5,000. At time t2, x withdraws. Whenever we say withdraw, let me say 1,000. At time t3, y checks balance. Y checks balance. What is the balance now? 4,000. At time t4, y withdraws. Let me say 1,000. Like that, they are doing the transactions. At time t12, x checks balance. Now let me say the balance is 1,000. At time t13, y also checks balance, which is 1,000. Y also checks balance. Now at time t14, x withdraws. Let me say at time t15, when y is trying to withdraw, it says insufficient balance. It says what? Insufficient balance. So just now it has shown to y that 1,000 is balance, and immediately it is saying insufficient balance. So whatever the output if you are expecting, if you are not getting this result, so the output what you are expecting, but you are not getting that result. So here the client will get, the user will get confused what is happening. So these confusions, we call them as concurrency problems. These confusions, we call them as what here? Concurrency problems. Okay. Now, so the output what you are expecting, if you are not getting, we call them as concurrency problems. So why we get concurrency problems? When two or more threads, if I consider x and y as threads, if they access same resource, then there is a chance of getting concurrency problems. Let us understand why we get this. If you take a method, make withdrawal, which takes the amount as argument to withdraw, and here we write the code for check balance first with some logic, and after that we write some code for withdraw, some logic. Now let us suppose it is a multi-threaded application. Now CPU has given time to x thread, to enter into this method. So x thread has entered into this method and x has checked the balance. So x has checked the balance here. Now since it is multi-threaded application, now CPU has given time to y thread to enter into this method. CPU has given time to y thread to enter into this method. So y also has entered into this method. Okay. So y also has checked the balance. Now CPU has given time to x thread to enter into the remaining piece of code. So x has entered and withdraw the money. So x has entered and executed the code of withdraw. Now when CPU gives times to y thread to enter into withdraw code, since the amount is already withdrawn, now there is no balance. So we get insufficient balance. So this is the reason we are getting problem here. Then the solution for this. The solution for this problem is simple solution given by Java is simple. We have to use a keyword synchronize it. We have to use just what keyword before the method? Synchronize it. When you make the method as synchronize it, only one thread will be running inside the method. Only one thread means when x enters into this method, until the total method is completed, y cannot enter. When y enters into the method, until the total method is completed by y, x cannot enter. X cannot enter means only one thread is running inside your method. So there will be only one thread running inside the method means when the total transaction is over, checking balance and after withdrawing, then only other thread can enter and check for balance and withdraw. So only one thread will be running inside the synchronized method. So this is the way to avoid concurrency problems. Simple solution, synchronized keyword here. So what is the point? When two or more threads access the same resource, then there is a chance of getting concurrency problems. Okay. Then what is concurrency problem? I have elaborated in the diagram. Then synchronization is used to avoid concurrency problems. Then how to avoid? Synchronized keyword is used for synchronization. Synchronized keyword is used for synchronization. Then synchronized keyword can be used for a method or block of statements only. Synchronized keyword can be used for what? A method or block of statements only. Like example, if you take a method xxx, if the complete method is having concurrency problem, then make the complete method as synchronized. Let us suppose if you are having a method, y which contains 100 lines of code. The method goes with what? 100 lines of code. But the concurrency problem is only with the 10 lines. A concurrency problem is what? Only with the 10 lines. Then you can make only the 10 lines as synchronized. Because if you make the complete method as synchronized, then the performance will get degraded. Because when we go with synchronization, only one thread will be running, no multi-threading. So performance will get degraded. Here we can make only some part of code as synchronized also, and this we call it as synchronized block. What is the point? In a synchronized context means method or block, only one thread will be running, which degrades the performance of application. Degrades what? Performance of application. Now, a small question to you. When you are developing software applications, which is more important? Correctness of the application or performance? Which is more important? Correctness, right? Correctness, because if your application is doing very fast, it's giving results very fast, but not having correctness, then there is no use. A simple example, if you go to ATM machine and you want to withdraw 5,000, but within seconds it is giving 3,000, will you accept? Performance is there? No, we want 5,000 only. Even it is taking more time also, we want our 5,000 back, because correctness is more important than performance. So if your application is not correct, then there is no use of application. So that's the reason, in order to achieve correctness, some places we need to lose the performance. That is the place where we go for synchronization. Clear? Any questions up to here?
Okay.
Right. Now let us move to the next one, the last one, inter-thread communication. Inter-thread communication. Let us suppose if you are having thread 1 is doing a task. Once the task is completed, we get the result, and the result want to be used by thread 2. Thread 1 is doing the task. Once the task is completed, we get result, and the result want to be used by thread 2. Now, let us suppose when thread 1 is doing the task, in between means before the task is completed only, in between thread 2 taking the value of result. Then will it get correct results? No, because the task is not completed. Before the task is completed only, thread 2 is taking result value, then we get wrong results, which is not good. So here they have to communicate now. They have to communicate. So thread 1 has to inform thread 2 that I am doing the task now. Once the task is completed, when the result value is ready, I'll inform, then you take the value of result. So that communication only we call inter-thread communication. And how to do is, it is done using wait, notify, and notify all methods. It is done using what? Wait, notify, and notify all methods. These methods belongs to object class. These methods belongs to what? Object class, not thread class, object class, the topmost class of Java hierarchy. The need of these methods is when thread 1 is doing the task, thread 2 should not take result value. So we have to make thread 2 to go to block state. How to make thread 2 to go to block state? Using wait method. So when we invoke wait method, then thread 2 will go to block state. Then when the result value is ready, we have to inform thread 2 to take the value of result. How to inform? Notify or notify all. So you can say when wait method is invoked, on a thread, the other threads will go to block state. Until notified using notify or notify all methods. Then what is the difference between notify and notify all? If there is only one thread in block state, then we can use notify method. If there is one thread or multiple threads in block state, we can use notify all method. So notify all method can be even used for one thread in block state, but for multiple threads compulsory we have to use notify all. One more very important statement. These methods means wait, notify, notify all. These methods need to be used in synchronized context only. These methods need to be used in synchronized context only. Else it will throw illegal monitor state exception. It is going to throw what exception? Illegal monitor state exception. Very important intro question, this one. Now let me elaborate all these parts using a program, inter-thread demo. Right click on threads package and say new class enter thread demo. Now let us take a class threadsum which extends thread. Let us take a class threadsum which extends thread. Now let us take a data member sum and override the run method. Override the run method. Now in this run method, let us find sum of 1 to 100. So I'm taking a for loop int I equal to 1, I less than or equal to 100, I plus plus. Then say sum equal to sum plus I. So this for loop will find sum of 1 to 100. Now coming to main thread, create object of thread sum ts equal to new thread sum. Create object of thread sum. Now by using thread sum object, call the start method. When we call start method, it will enter into run and it's going to find sum of 1 to 100. Now in main thread, display the value of sum equal to ts.sum. So in this program, who is doing the task? Thread sum is doing the task and main thread is taking the result value. Main thread is taking the result. Now see the output. Output is important to understand. See the output. We are getting sum as 0, but sum of 1 to 100 is 5050, 5050. But we are getting sum as 0 here. Let us run the code again. We are getting 0. Sometimes even we get correct result 5050 also. Now let us understand why we are getting sum as 0. See here, when you run the program, which thread goes to runnable state first? Main thread. Main thread will go to runnable state first. After that, when you set ts.start, ts thread also will go to runnable state. Now, out of these two threads, can you guarantee which thread will execute first? Can you guarantee which thread will execute first here? No guarantee, right? That's the point what we discussed. So runnable state is like what? Ready to run, waiting for CPU time. Waiting for CPU time. But for which thread your CPU is going to allocate time, that we cannot decide. Let us suppose CPU has given time to main thread first. So when you say ts.start, before it enters into run, CPU has given time to main thread. So this line of main thread will get executed. That is the reason we are getting sum as 0, because this for loop not been executed. So we get the sum as default value 0. Now the point is, this line of main thread should not get executed until the for loop is completed. Clear this point? This line of I should not take the sum value, the result value, until the for loop is completed. So what we should do? We have to make main thread to go to block state. When you make main thread to go to block state, this line of code will not get executed. How to make main thread to go to block state? By using wait method. When you say ts.wait, the other thread, who is other thread? Main thread will go to block state. So this line of code will not get executed. See, we are getting error under wait because wait method throws interrupted exception. So checked exception, you can add the throws declaration. Then, now when I should inform main thread to come back to runnable? After for loop. So once the for loop is over, you can say notify or notify all. That's it. Now see, when we run this piece of code, we get say an exception, illegal thread state exception, because we have to use these methods in what? Synchronizer context, like this. Synchronizer of the object name. Which object is calling wait method? TS. So notify also synchronize. What is object name? We don't know. So we'll say current object means this. So when we run, we get see result as 5050. How many times you run, we get the correct result 5050. So before someone takes a result value, if any thread takes a result value, we have to say wait. Once the task is completed, we have to use notify. Simple. So any questions, anyone? So please practice this. Only the difficult topic in core Java is multi-threading. Okay, if you recap 1 or 2 times, it's very simple, right?
Hi Raj, Sindhu here.
Yeah.
Recently they asked one question like a scenario. Let's say we have 3 threads, T1, T2, T3, and we make T1 to sleep for like 1000 milliseconds. So at that time, what this T2 and T3 will be like executing, can we utilize it, or in which state it will be? Can we
It will be
use
in
this
runnable
also
state.
in it?
Yeah, we can use it. It will be in runnable state. Because only T1 went to block state using sleep method. But other threads are there, no? T2 and T3, they will be in runnable state. So it can use the resource. Only T1 goes to block state. That's the objective of asking that question. So when you say T1 dot sleep, we think that other threads will go to block state. No, only T1 will go to block state. So sleep means, simple way to remember, sleep. I want to sleep. So I am going to sleep, not others. Wait. See how to understand. Wait. So if I say wait, if I am saying wait, who has to wait, myself or others?
Others.
Others. Sleep means I am saying myself sleep. So I should sleep. Means the current thread only will go to block state. When I use wait, the other threads will go to block state.
Okay,
So that
and
is asking that question.
can we have this wait method, like wait for 10 seconds, like the time passed in the wait method? Can we do that
Yeah.
also?
Yes, we can even do that also. We can even do that. But this is not guaranteed one. So can we guarantee that in 1000 milliseconds the code will get executed? No. So this is not suggested one. Some cases they use, but not preferred to use this one. Got it?
Okay. If there are like three threads, if I call this wait, like I have to say wait for T2 and T3. Like how do I specify? Like I'm executing T1, I have to
So
make.
when I say wait, all other threads will go to block state. All other threads. If you are having 100 threads also, all will go to block state. Only first thread will be whichever. If I say T1 dot wait, and if you are having T100, only T1 will be in runnable state. All other threads 99 will go to block state.
Okay.
Okay.
Yeah.
So because until the task is over, I don't want any other thread to come and interrupt. Should not use CPU resource until my task is completed.
Okay.
Got it?
Yeah, got it, Raj.
Yeah, Raj, the same topic discussion, like uh, having these scenarios, like what will be the major differences between wait and sleep methods?
The sleep method only we use like when you want to make a thread to go to block state for some interval of time. So sleep method majority cases we use for gaming applications. Or if I want to display the timer, so every 1 second the second should get increased. In that cases that animated part we do by using sleep method. So wait method and notify this for inter-thread communication. Threads are communicating. So when threads are communicating, when one thread completes the task, then only the result should be taken. In that case, we use wait and notify. Until we complete, the other thread should not take the results value. So when you are doing a database operation, until I insert the record, and when the insertion operation is totally complete, then only we can get the records from your table. If the such type of scenario is there, then in that case we use wait method. And once the transaction is totally complete, then we'll inform to take the records from the table. Got it?
Yeah, like it, we can also imagine the same scenario also in the banking application also, right?
Yeah, main thing, we use this type of things for banking applications.
Mm-hmm.
Okay.
Yeah.
Right. So next class tomorrow, we start off with one more new topic and very important one, collections. Okay, very important one. So next 2 classes will go for collections. Thank you all.